Hi everyone, welcome back. Let's take a look at problem 2, which wants us to find the centroid of this figure. Well, if you wanted to find the centroid and everything was uniformly, if you want to find the centroid of this figure, you can kind of guess that it would be somewhere around in here. Because if I were to hold it here and, try and hold it up and have it balance, it looks like the center of gravity or the centroid would be somewhere around in there. So let's figure out what it is exactly. So the first thing we need to do is subdivide this into two areas that we can find the centroid or the center of each of the smaller areas. And so, well, I could follow this up and have the three sections, or I could cut this way, and then I'd have a top rectangle and a bottom rectangle. Well, let's do that. So we need to find the area. So F is 3.5, and FT is, 1.69? So the top rectangle would be 3.5 times 1.69. Now the bottom rectangle, well, it tells us the whole height from here all the way down, that's W, and then we know the FT, which is 1.69, so we're going to have to subtract to get this area. To get this length. And so this would be all of W, which is 4.4, and then minus FT, which is the 1.69. So that's what I did there. And then times the width is 1.69. And so I do those calculations and we get 10.4949 square millimeters. Okay, so that's the first thing we need to do. The second thing we need to do is place an X and Y axis. And so we need to place an X and Y axis somewhere. Well, where are we going to put it? We can put it anywhere we want because the problem doesn't tell us. Oh, no, it does tell us. I'm sorry. It says use the bottom of the figure for the x-axis and the middle of the vertical bar for the y-axis. So our x-axis is going to be down here. That's x. And then our y-axis goes through the center of the vertical bar. So just like this. And so this is our y-axis. And that's exactly where I would have chose to put the x and y axis. I know in the last problem we put the entire shape in the first quadrant, but in the last problem our shape wasn't symmetric. And if we have a symmetric figure, it becomes really easy to find the centroid because we can put the y-axis right down the line of symmetry, and it'll be a lot easier to find our x-coordinates. So what do I mean by that? Well, the first thing we need to do is find the centroid for this top rectangle. Well, left to right, we're going to go in the middle. Well, in the middle is where the y-axis is. So if the centroid is there, our x-coordinate is going to be 0 because we're not going to go left or right any. And then how far up do we go? Well, we know FT is 1.69 millimeters, so we would go up half that distance for the middle. So half of 1.69 is 0.845. So we go up 0.845. But our x-axis is down here, so we have to go up this entire distance and then up the other 0.845. And so that would give us 3.555. Okay, so the top centroid would be 0 and then 3.555. Okay, so for the bottom rectangle, the centroid's going to be right in the middle. And so since we have the y-axis going right down the center of this bar, then we would go left or right, 0. So our x-coordinate would be 0. And then the vertical, how far up or down do we go? Well, we would go half of this distance. Well, that distance is 4.4 minus 1.69. And so half of that distance is 1.355. And so those would be the two centroids for the two rectangles. Okay, so now that we have the centroids, we can do the fun math. Well, what I have done is I've drawn a table here to help us with all that. And so we could either do the math like on a piece of paper like this, or we could use a table. I kind of like the table because it like lays everything out for us. So let's just, look at the area. We found the area of the top rectangle and the bottom rectangle and added them together. Okay. And then we can put in the centroid, the x bar, y bar for the top rectangle. So 0, 3.555. And then for the bottom rectangle, put in that centroid. So 0, 1.355. And now this is where we can do the math. And so remember about the y, the moments about y, the y-axis. We take the area of the rectangle and then the distance from the y-axis. So that's our x-coordinate. And so we would have the area times the x-coordinate would be our m sub y. So it kind of goes, and it goes over here. It's kind of like we're playing leapfrog. And we do that for the bottom rectangle. So area times 0 is equal to the moment. Okay. And then we need to do that for the y's. And so we would take the area and multiply by the y-coordinates in our centroids, and that would give us the moments about the x-axis. So we go, I kind of think of it as a leapfrog. So here we do a little leap and then a big one, and here we do a big one and then a little one. So 5.915 times 3.555 is 21.0278. And then this area times this y-coordinate is equal to this moment. Okay, and then we just add them up. Well, 0 plus 0 is 0. That's why I said, if you can put the y-axis right down the center of symmetry, then it makes at least these x-coordinates real easy. Okay, so then we add these up, and then we divide by the total area. So the moments about the y-axis, that's our x-coordinate. So 0 divided by anything is 0. And then to find the y-coordinate for the centroid, you take the moments about the x-axis, because that tells you like the distance from the x-axis, and divide by 10.4949, and you get 2.5949. And so our centroid for this shape would be, you go left or right 0, and then you go up 2.5949. So, I don't know, somewhere right in there would be the centroid. So, the center of that shape would be 0, 2.5949. Okay, well, let's go on and take a look at the third problem.